Hello, welcome to lesson 12-2. Here we're going to practice solving quadratic equations using factoring. So we are going to use factoring, use factoring to solve a quadratic equation. And we're also going to describe the connection between the zeros of a quadratic function and the x-intercepts of the function's graph. So as you know, a quadratic equation is in the form of ax squared plus bx plus c. And what we're going to do today is solve this equation by factoring, or find its zeros using factoring and what's called the zero product property. Okay, so the way we do that is we start with the original equation and make sure it's set equal to 0. Then we factor the left side, apply the zero product property, which means set each factor equal to 0, and then finally solve each equation for x. When you're done, you may have two answers. For the most part, you'll have two answers. All right, let's try a couple of these. So I'll use the space below to show my work. So for question A, we are going to solve x squared minus 5x minus 14 equals 0. And to do that, we are going to set up, since it's a trinomial, set up some binomial factors. And since it's a level 1 trinomial, we know those are both x's, and we need to find the two numbers that multiply to negative 14 and add to negative 5. And those two numbers are negative 7 and positive 2. You could check your factoring with FOIL, but we know we're right, so we're going to go ahead and set each of these factors now equal to 0. So x minus 7 equals 0, and x plus 2 equals 0. And that's the zero product property. Now we're going to add 7 to both sides, so x equals 7. We'll subtract 2 from both sides, and that means x equals negative 2. So our two solutions for this equation are negative 2 and positive 7. Okay, so you can plug each one of these in for x, and you will get a 0 out. Let's try part B. So part B's factoring looks like we have 3x squared minus 6x equals 0. There are only two terms, but it's not a difference of squares. It's actually a GCF. I see a 3 and an x I can factor out, which leaves x minus 3x times 2 is 6x equals 0. And again, we'll use the zero product property. So we want to know, when does 3x equal 0, and when does x minus 2 equal 0. So 3x equals 0, divide by 3 on both sides, when x is 0. So 0 is a solution to this equation. Add 2 to both sides. 2 is also a solution. So we have a 0 and a 2. For our third problem, part C, we actually have an equation that's not set equal to 0. And so that's actually going to have to be our first step. We're going to want to subtract 18 on both sides in order to get an equation that is equal to 0. We'll do C. So we'll have x squared plus 3x minus 18 equals 0. Now it's ready to be factored. So if I break my trinomial down, again, it's a level 1 trinomial. It will be x times x, and then I need two numbers that multiply to negative 18, but add to positive 3. And that is going to be 6 and negative 3. So we'll have an x plus 6 and an x minus 3. Now we'll set both of those equations equal to 0 to solve for x. So subtract 6 on both sides. We know that x equals negative 6. Add 3 to both sides. X equals 3. So we actually have two answers again. It's negative 6 and positive 3. Okay. Now if you know the solutions to a quadratic equation, you can write the equation. So we can actually write an equation in standard form if we are given solutions to the equation. Okay, so let's look at try these B and we can walk through one of them. So it says write a quadratic equation in standard form, and they give us the two solutions. We have x equals -1 and x equals -7. So the first thing that we're going to do is we're going to write the linear equations that correspond to these solutions. So if x equals -1 is a solution, then it must have come from x plus 1 equals 0. And if x equals -7 is a solution, it came from x plus 7 equals 0. So those are the linear equations that correspond to the solutions. Now we can write them as factors. So x plus 1 times x plus 7. And if we multiply that out, we get x squared plus 7x plus 1x is plus 8x. And then 1 times 7 is plus 7. And so when we're all done, we get an equation if we set it equal to 0. So we'll do x squared plus 8x plus 7 equals 0. Okay. In part B, we get a little bit harder problem because our solutions are actually fractions. So if our roots or our zeros are x equals 2/5 and x equals -1/2, when we write our equations, they are definitely going to look a little bit different. So we can still write our factors as we did before. So if we write our factors as x minus 2/5 times x plus 1/2, and we do our FOIL, we just get a little bit of a messy answer, but we can work through that. X squared, and then we get plus 1/2 x, and we get minus 2/5 x, and then we get minus 2/10. And it will be a little easier to work with if we multiply through by the least common denominator. So since both 2 and 5 and 10, actually all three, 2, 5, and 10 can go into 10 evenly, we'll use 10. So x squared times 10 is 10x squared. 1/2 times 10, 1/2 x times 10 is 5x. -2/5 times 10 is -4x. And -2/10 times 10 is minus 2. So we will get 10x squared plus 1x minus 2 equals 0. And that is answer choice B. Okay, let's try maybe one more of these. We can write a quadratic equation in standard form. Let's say we use part C. So we're going to write our factors first. We're going to have x minus 2/3 times x minus 2 equals 0. X times x is x squared minus 2x minus 2/3 x plus 4/3 equals 0. Now if we go in and multiply both sides of the equation by 3, we will be able to clear the fraction. That'll give us 3x squared minus 6x minus 2x plus 4 equals 0. So 3x squared minus 8x plus 4 equals 0. So those are just a little bit harder roots to deal with, or zeros to deal with. Okay. On the next page, we're going to see a graph. Okay. And we're going to identify the x-intercepts, and we're going to also talk about the vertex a little bit in this graph. Okay. So in this graph, the x-intercepts, we can see if we zoom in a little bit, are at 5 and at 1. So we can say the x-intercepts are at, a couple ways to write that. You can say x equals 5 and x equals 1. You could also say 5, 0 and 1, 0. Now the x-coordinate of the vertex, here's our vertex right here. So that looks like it's at over 3, but down 4. So our x-coordinate of the vertex is at 3. So it says describe the x-coordinate of the vertex with respect to the two x-intercepts. Well, the x-coordinate of the vertex actually is right in the middle of those two. It's the average of those two. So 3 is the average of 5 and 1. So the x-coordinate of the vertex will be right in the middle of the two x-intercepts. Okay, so we're going to take this equation that was graphed, this y equals x squared plus 6x plus 5, and we're going to factor it. Okay, so if we factor it, again, it's a trinomial. So we have x times x. Now we need two numbers that multiply to positive 5, but add to negative 6. Multiply to positive 5. So negative 5 and negative 1 will work. Okay, so now each of these factors that we found in part A is a linear expression. It says solve each of those two by setting them equal to 0. So if I set x minus 5 equal to 0 and x minus 1 equal to 0 and I solve, guess what I get? X equals 5 and x equals 1. So to solve the related equation, well, we just did that. X equals 5 and x equals 1. So when we solve a quadratic equation, what we're actually finding are the x-intercepts. So we refer to them as x-intercepts and zeros, and even sometimes we call them roots. Okay. And so we'll kind of wrap that up on this page over here by talking a little bit about what we just found out. So the linear factors that we found in 4a will lead us to getting the x-intercepts in the function when it's graphed with a y. So if I have a expression x squared minus 6x plus 5 and I factor it, it will actually give me the x-intercepts for the graph of the y equals. So this will be a graph of our parabola, okay, and it will get me those x-intercepts. So without graphing, how could we determine the x-intercepts of this function? Well, what we would want to do is set it equal to 0. And we could say x squared plus x minus 12. We can factor it. So two numbers that multiply to 12, negative 12, but add to positive 1. So x minus 3, and x plus 4 should do it. 4x minus 3x is 1x. Set them both equal to 0, and you'll have your x-intercepts. So we add 3 to both sides, and we get x equals 3. Subtract 4 to both sides, you get x equals negative 4. Those will be the x-intercepts of the graph. So the x-coordinates of the x-intercepts of a quadratic function are the zeros of the function. The solutions of a quadratic equation are called the roots of the equation. So when we say 0, when we say root, and we say x-intercept, it's all the same idea. The quadratic function y equals ax squared plus bx plus c is related to that same function set equal to 0 by letting y equal 0. So why do we think that the x-coordinates of the x-intercepts are called the zeros of the functions? Well, they're called the zeros because these x values occur when y equals 0. These x values occur when y equals 0. Okay? The real roots of an equation are the zeros of a quadratic. The roots of the equation are what we call the zeros of the quadratic. All right, we've got a few more practice problems we could do, but we're going to save those for class time. Okay, and on the next page, we've got a good assignment for you to work on for over the weekend. That's it for this lesson.